Okay, so without wasting any other time, I want us to now move into the theorems. I'm beginning with the first theorem, which is very, very simple. Now, just before I dive into this, I want you to know something. Most of the time in WAEC or in NECO, they may not necessarily ask you to prove all the theorems there are in circle theorem. They might just pick one or two, and those particular theorems they usually ask, we are going to solve those ones with the purpose of actually committing them to memory, all right? But these other ones that we're going to do right now, you don't have to worry so much about putting them in your memory. Remember, there's something I told you that we're going to understand the principle and the application. I'm more interested in teaching you the application. And by the application, I mean solving those problems. Okay? So I want to teach you the how to prove some of these theorems so that when I start solving, you will actually understand the principle behind those solutions. It will help you even reason it out much better. All right. Now, the first theorem here I want us to address is this one. It says a straight line which joins the center of a circle to the midpoint of a chord, which is not a diameter, is perpendicular to the chord. Don't bother yourself about all the big grammar that they spoke here, okay? So this is simply what they are telling you to do. This is my rough work, okay? Now this is a circle, all right? Now what do they want you to prove? They want you to prove that it says a straight line which joins the center of a circle to the midpoint of a chord. So what is the center of the circle? This is the center of the circle. And then it says midpoint of a chord. That means there is a chord. So let's go back to the first sentence. A straight line which joins the center of a circle to the midpoint of a chord. So this straight line joins the center of the circle to the midpoint of a chord. So the midpoint of this chord. Now it is telling you that that chord is not a diameter. So don't go and draw the chord from here, dividing the circle into two parts. No, that's why I said which is not a diameter. So which means the chord could be anywhere else, but definitely not the line that divides the circle into two equal parts. Okay. Now, what is the point it's making? It's saying that that particular straight line is perpendicular to the chord. What's the meaning of perpendicular? Perpendicular is any line that forms an angle of 90 degrees with the horizontal. It forms an angle 90 degrees, which is popularly called the right angle, okay? So whenever you use your protractor and you measure this angle, it's going to give you exactly 90 degrees. So it's telling you that this straight line that runs from the center till it touches the midpoint of this chord must always be 90 degrees when you measure this particular angle here. So the problem is, how do you prove it? How do you actually show that this hypothesis is true? So that's what we're going to prove right now. So let me keep my rough work and come back here. So we've already drawn the circle. I have mapped out the proof. I'm going to explain it to you in very simple terms, okay? So we want to prove this. Now, when you're proving a theorem, there are 3 or 4 fundamental roadways, all right? And that is, what are you given? What are you required to prove? Do you have any need to do any construction? And then the actual proof. So what does this mean? Very simple. So you're going to take note in the diagram. What are you actually given? So what do you see here? You're given a circle that has a center. The center is usually marked by O, all right? So you're given a circle that has a center and it also has a chord AB. This is a chord AB. So that's what we're given. Very simple. A circle with a chord AB, all right, and center O. So this particular M, we just use it to mark this place where this line stops, all right, this particular point. So we have written out what we are given. Now the next step is, what are we required to prove? So what are you actually required to prove? Now go back to the diagram and even the theorem. You're required to show that this line that comes from here down to this place, if you measure the angle it forms here or here, it will give you 90 degrees. That's what you're required to prove. Okay, the next step. Do we have any need for construction? This part is usually optional. Sometimes you might need to construct or you may not need to construct. So what do we mean by construction? So sometimes they might give you something and they say prove it. But before you can prove it, you might need to introduce another line or maybe any other thing in that diagram. Most of the time is a line that can help you to bring out a proper image of what you want to prove. In this case, we are going to need to construct. So what are we constructing? It says draw line OA. So when we express it like this indicates line OA and line OB. Okay, so this one is for your own solution. So let me construct it. You can indicate using broken lines so that the examiner will know that that is a construction. So I'm going to indicate using broken lines. So line OA means from here to here. Okay, and then line OB, that is from here to here. Like I said, the essence of construction is it's going to bring out a correct image that can really help you see what you're trying to prove. As you can see, because we've introduced these lines now, we are seeing the image of a triangle. You can even see 3 triangles here, 1, 2, and then the bigger one, which is 3. So we now have an image. So the main aspect now is the proof, which is this one. So we're trying to prove that when we measure this place, we must get exactly 90 degrees, even if you don't use a protractor to measure it. So these are the steps of the proof. But first, line OA is equal to line OB. Now you remember, anything you say in circle theorem, you must write down the reason. So if you're making a statement now, you are saying this line OA is equal to line OB. What's your reason? See our reason here, radii. And why is this a valid reason? Remember, we earlier said that the radius is a line that runs from the center of the circle till it touches any part on the circumference. So if you drew this line here and you drew this line to this circumference, both of them must have the same length. So it is right to say that line OA is equal to line OB because both of them are radius. So that's my reason in bracket. Now the next step, line AM is equal to line BM. Okay, line AM is equal to line BM. Now, what is the reason there? This one says it is given. So this is already appearing here in the diagram. Okay, that is why we write the reason as given. Now let's come to the third step. It says line OM is common. What does that mean? This is line OM. This is a triangle on its own. This is a triangle on its own. Now both of these triangles are sharing this same line. That's why we say it is common. So they are sharing the same line. Now what is the importance of identifying that line OM is common? It is because by making that statement now and confirming it, you now realize that this angle AMO is the same as angle BMO. Now, in mathematics, mostly we use this symbol here to represent angles. But this symbol is actually pointing to the angle in the middle, the letter in the middle. Take note, whenever it is represented like this, it's pointing to the letter in the middle. So what do we mean by angle AMO? Come back to the diagram. Angle AMO. So we are talking about this very angle. And what do we mean by angle BMO? Remember we said the one in the middle, angle BMO. We're talking about this very angle. So what is the point? It is telling you that this angle is the same with this angle. That's why we represented it like this. And the reason is SSS. What does SSS mean? If you studied similar triangles, you realize that this simply means side, side, side. So we have been able to prove that you see these two triangles like this that are facing each other in opposite directions. It is exactly the same triangle because this side is the same as this side. This side is the same as this side. And this side, since they are sharing a common side, they are both the same with each other. So the reason that this angle here must be the same as this angle is because of side property of triangles. Now the next step, thus angle AMO plus angle BMO is equal to 180 degrees. Remember, you must give your reason. And what's the reason? Sum of angles on a straight line. Now this is something you should remember, because when you have this is straight line. Let's say you have a line that is cutting it across here. What is the value of this angle plus this angle? So the general rule in mathematics says the sum of angles on a straight line must give you 180 degrees. So if this place is 50, for example, that means here must be 130. If this place is 70, that means here must be 110. In each case, the sum of angles on a straight line must give you 180 degrees, all right? Now, in the case of this very one, since you have proven that this angle is the same with this angle, another step is, what if I decided to total them together? I must get 180 degrees. Now, since I have shown here that angle AMO plus angle BMO is 180 degrees, therefore, since this is equal to this, which you have already shown here, that means that angle AMO is half of 180 degrees and angle BMO is half of 180 degrees. Since both of them are the same, are you getting the point? So since both of them are the same, that means this one is half of this number and this is also half of this number. Now, if you take the actual half of 180, you're going to get 90. That is for angle AMO. And if you take the half of BMO, you're also going to get 90. So that proves that this angle is 90 and this angle is 90, which means it is perpendicular, because angle 90 degrees means perpendicular. So we have been able to prove that it is perpendicular. Now, favor, again, I just want to bring to your attention, don't look at these things as ambiguous. They are not ambiguous. They're just very little, okay? And like I told you, don't worry so much about putting this in your memory. I just want you to understand the principle behind circle theorem. And that's why I'm starting with something very, very fundamental, okay? Now, the more important aspect of this is the next thing I want to do now. I want to give you an example on this particular theorem, which is the application I've been talking about. So the next video I'll send you now, I'm going to give you an example that captures what we just learned in this principle, all right?